In this session, we'll be having a look at the AQA Foundation Combined Trilogy paper from the year 2018. Make sure you have a ruler, a calculator and the periodic table. This question is about structure and bonding. Figure 1 shows part of calcium oxide and what type of bonding is present in calcium oxide. So we've got positive and negative ions, so this is ionic bonding. Figure 2 shows a particle of methane. What type of particle is present in Figure 2? This type of particle is called a molecule. Figure 3 shows the structure of carbon C60. And what do we call this type of structure? This type of structure is called a fullerene. Figure 4 shows the structure of graphite. Describe the type of bond A labelled in Figure 4, and this is a covalent bond. In graphite, each carbon atom forms 4 bonds with other carbon atoms as shown in Figure 4. How many electrons does one carbon atom use to form one bond? So in one covalent bond, each carbon atom will share 1 electron. Figure 5 shows apparatus used for electrolysis. Complete the sentence. Choose the answer from the box below. So Figure 5 shows that copper conducts electricity as a solid. Complete the sentence. Choose the answer from the box. Copper conducts electricity because movement of delocalized electrons. Figure 6 shows the apparatus used to investigate the effect of electricity on a solution of sodium chloride. So Figure 6 shows that sodium chloride conducts electricity when dissolved. And we know it's dissolved because it's a solution and not a liquid. Sodium chloride is made up of ions. Figure 7 shows the apparatus used to investigate the effect of electricity on solid sodium chloride and molten sodium chloride. So we have our solid here and our molten here. Now we do the investigation and we compare the two. So for the solid, we can see that the filament bulb does not light up, and that's because it does not conduct electricity. For the molten, the filament bulb does light up and it does conduct electricity. So sodium chloride, solid sodium chloride does not conduct electricity, and that's because the ions are fixed. Molten sodium chloride does conduct electricity, and that's because the ions can move. This question is about the halogens. Which group in the periodic table is known as the halogens? And that would be group 7. Group 1 is the alkali metals, group are the alkali earth metals, and group 0 is the noble gases. A fluorine atom has 7 electrons in the outer shell. Figure 8 shows part of the dot and cross diagram to represent a molecule of fluorine. Complete the dot and cross diagram. So because we're in group 7, we have 1, 2, 3, 4, 5, 6, 7 electrons for this fluorine, and then 1, 2, 3, 4, 5, 6, 7 electrons for the second fluorine, and that shows that the outer electron shells are full. Chlorine reacts with potassium bromide solution. Complete the word equation. So chlorine plus potassium bromide, the chlorine displaces the bromide, so we end up with bromine and potassium chloride. What type of reaction happens when chlorine reacts with potassium bromide solution? So we have a more reactive metal displacing a less reactive metal, and that's a displacement reaction. Complete the sentence and choose from the box. Chlorine is more reactive than bromine. This is because chlorine gains an electron more easily. How does the size of a chlorine atom compare with the size of a bromine atom? So a chlorine atom is higher up, therefore it's smaller than a bromine atom. Give a reason for your answer, and that's because chlorine has fewer electron shells. Fluorine reacts with chlorine to produce this molecule here, ClF3. Balance the equation for the reaction. So we've got 2 chlorines and 2 chlorines on the product side. We've got 2 fluorines here, and we've got 2 times 3, which is 6 on this side. So therefore, to get 6 fluorines on this side, we're going to have to do 3 times F2, which balances that out. Explain why fluorine is a gas at room temperature. Now, fluorine is a simple covalent structure, so that means there's weak intermolecular forces between the molecules which need little energy to break them. This question is about acids and bases. Which ion is found in all acids? And that's a hydrogen ion, which is this one here. Zinc nitrate can be produced by reacting an acid with a metal oxide. Name the acid. Now, because we've made zinc nitrate, the acid would have to be nitric acid. The metal oxide that we use now, because we've produced zinc nitrate, the metal oxide would have to be zinc oxide. In an equation, zinc nitrate is written as ZnNO3 with a 2 outside the bracket. What does the AQ mean? The AQ means it's aqueous, which means it's dissolved in water. The pH of a solution is 8. Some hydrochloric acid is added to the solution. Suggest a pH after mixing. Now I'm going to put 7, but anything below 8 would be correct. Table 2 shows the solubility of 3 solids in water at room temperature. So we've got phosphoric acid, silicon dioxide, and sodium hydroxide. Silicon dioxide is the one that does not dissolve. A teacher labels 3 solids A, B, and C, and the students get information in table 3 below. Describe a method that could be used to identify the 3 solids A, B, and C. So first of all, what we could do is we could put all of the solids into water, and the one that does not dissolve would be the silicon dioxide. Then we could add a universal indicator to the solutions. The one that has a pH below 7 would be the one that's an acid, so that would be phosphoric acid. The one that has a pH above 7 would be the one that's alkali, and that would be the sodium hydroxide. And the one that has a pH of 7 is the one that hasn't dissolved, which would be the silicon dioxide. This question is about elements in group 2 of the periodic table. Figure 9 shows the positions of elements A, B, C, and D, and which element is in group 2. So we've got group 1, 2, 3, 4, 5, 6, 7, and 0, and the one which is in group 2 is B. Group 2 metals break down when heated to produce a metal oxide and a gas. Name the 2 products when calcium carbonate is heated. So the metal oxide would be calcium oxide, and the gas would be carbon dioxide. What type of reaction happens when a compound breaks down? So this would be decomposition, and because it's using heat, it's actually thermal decomposition. The metal carbonate takes in energy from the surroundings to break down, so that type of a reaction is endothermic. If it was giving out energy, that would be exothermic. Figure 10 shows the volume of gas produced when a group 2 metal carbonate is heated. The student collected 5.2 decimeters cubed of gas. What mass of group 2 metal carbonate is heated? So I've drawn on the lines onto the graph, so we can see at 5.2 we get 32 grams of mass that's heated. Now we've got to calculate the mass of group 2 metal carbonate needed to produce 24 decimeters cubed of gas. We do not have 24 decimeters cubed on our graph here, so we have to extrapolate it. So 32 grams gives us 5.2 decimeters cubed. So if we do 32 divided by 5.2, that tells us how much 1 decimeters cubed will give us. And then if we times it by 24, that tells us that we need 148.8 grams to produce 24 decimeters cubed. The student calculates the gradient of line in figure 11. So the student has made 2 mistakes. So the correct formula is increase in volume of gas divided by increase in mass. And the student does a calculation 4 divided by 715. So the 2 mistakes, mistake 1 is, first of all here, the increase in mass has gone from 1 gram to 4 grams. So the increase is actually 3 grams, not 4. Mistake 2 is that it should be the increase in volume, which is 715, divided by the increase in mass, which is 3, not 4 divided by 750 as shown there. And the calculation, if we do this, 750 divided by 3 gives us 250 centimetres cubed per gram. The student repeated the experiment with a different group 2 metal, XCO3. The relative formula mass of XCO3 is 84. The relative atomic mass of carbon is 12 and oxygen is 16. Calculate the mass of X, therefore name the element X. So XCO3 has a mass of 84. Now the carbon has a mass of 12 and 3 times 16 for the oxygen is 48. So the mass of the CO3 is going to be 60. Therefore, to work out the mass of X, we would do 84, which is the whole mass, take away the mass of CO3, which is 60, which leaves 24. So the mass of X is 24, and if we use our periodic table, that shows us that X must be magnesium. This question is about electrolysis. A student investigates the mass of copper produced during electrolysis of copper chloride solution. Which gas is produced at the positive electrode? So we've got copper ions and we've got chloride ions. Chloride ions are negative, so they're attracted to the positive electrode, so we would have chloride. During electrolysis of copper chloride, copper is produced at the negative electrode at the cathode. What does this tell us about the reactivity of copper? So copper must be less reactive than hydrogen, otherwise a hydrogen gas would be produced. Then we have a student's results table, which is table 4, and we've got experiment 1, 2, and 3 and the mean. The question says determine the mean mass of the copper produced after 3 minutes. Now that's not on our table of results, however we know it's going to be halfway in between 1.2 and 2.4. So halfway in between 1.2 and 2.4 would be 1.8. Figure 13 shows sodium and chlorine in the periodic table. So we've got to name one difference and one similarity between the two. The difference is sodium has 1 outer electron and chlorine has 7 outer electrons. Similarity is that they are both in period 3, which means they have 3 electron shells. Sodium atom reacts with chlorine to produce sodium chloride. Describe what happens. So the sodium will transfer its outer 1 electron to the chlorine, which gains 1 outer electron. Calculate the mass of X of copper produced in experiment 2, and this is the information from table 4. So, to work out what the total mass of experiment 1, 2 and 3 would be, it's going to be 3.06 times 3. And from that, if we take away the mass of experiment 1, as well as the mass of experiment 3, that would leave the mass of experiment 2, which calculates as 3.15. Then for the next part of the question, it says copper chloride solution is used in the investigation containing 300 grams per decimeters cubed of copper chloride dissolved in 1 decimeter cubed of water. So that means we've got 300 grams in 1,000 centimeters cubed, because that's what a decimeter cubed is. The student only uses 50 centimeters cubed, and we've got to calculate the mass in 50 centimeters cubed. So we're using 50 out of 1,000. And that is 0.05. So that means we are going to have 0.05 times the 300 grams, which equals 15 grams of solid in 50 centimeters cubed. The reaction between sodium and chlorine is an exothermic reaction. Complete the reaction profile diagram for the reaction between sodium and chlorine. So the products are going to have less energy than the reactants because it's exothermic, and to get the reaction going we have to put in activation energy. A student plans a method to prepare pure crystals of copper sulfate. The student's method is add 1 spatula of calcium carbonate to dilute hydrochloric acid in a beaker. When the fizzing stops, heat the solution with a Bunsen burner until all the liquid is gone. The method contains several errors and does not produce copper sulfate crystals. Explain the improvements the student should make to the method so that the pure crystals of copper sulfate are produced. So first of all, it's important that we understand that we're trying to make copper sulfate crystals. So to make copper copper sulfate crystals, we need to use copper carbonate and not calcium carbonate because the metal is incorrect. Also, if we're producing a sulfate, we need to use sulfuric acid and not hydrochloric acid because hydrochloric acid would make a chloride and sulfuric acid will produce a sulfate. Also, when we're trying to do crystallization, we need to keep adding the solid until no more dissolves. Then we filter to get rid of the solid so that we have the solution left behind, which we then gently heat until there's a little bit of liquid left behind. And then we leave that little bit of liquid to cool and crystallize. We do not heat it to dryness.